Hi everybody, my name is Mtwana Nkosi. So let's get started. So before you get started, right, it's very, very crucial for you to read the question, because if you don't read your question very, very careful, means you're going to answer the question based on not how you ask the question to answer, okay? Now, let's say here, so the reason why I came with this diagram, because it's gonna help us to answer this in detail, because they're not gonna answer like they all the time. So now, before we go further, right, please come right here, subscribe to this platform right here. See what I'm saying? Just come subscribe here, and it's very, very important so that you can get the notification automatic. Apart from that, we got program, apart from the academy, I have a program of feeding the homeless and dressing them. Clean them sometime. Is giving back program. So go there. Do your donation. We appreciate that, so we can continue with this movement. You see what I'm saying? Only it's convenience, okay? It's just only if it's convenience for you, okay? So go to my other YouTube channel called Mtwana Nkosi. You can go to Facebook, YouTube, and Instagram. You can see what we do. Now let's get back here to our crucial things that we have to do, our main purpose of the program, okay? So let's say here, in a simplified diagram, means this is a diagram here, the machine is shown just like how we see. Now they say, is this direct motor or DC motor? Let me explain to you what that means. Look, you see, here we have a cell. How you know cell? Like, look, if somebody give me this is cell, because I have a positive and negative, it's only one. But if it's more than one, let's say you got another one here. This is a battery here, because it's more than one cell. This is cell and a cell, so together make what? Battery. But for our case, it's just one cell. But remember, this is a positive here, because there's a positive. Whenever there's a longer line, it's positive. Means the longer line on the other side is positive. Look now, the moment you place the battery here, the current is going to go this direction, all the way. You see what I'm saying? Because this is negative, it's going to come all the way and it's going to enter again here, because that's a negative, all the way. Okay? So look, if the current move this direction, the funny and very interesting part is, very interesting part. Just a second. Okay, the interesting part is, sorry, my pen is kind of freezing a little bit. Apologize, okay? Well, no problem. I'm going to use one pen, red one. I want to mix the pen, okay? So the interesting part is, man, let me try one time. Nah, it doesn't want, no problem. My pen is freezing, guys. So, okay, no problem. Let's go. So the interesting part is, if this current move this way, the coil is going to move, okay, opposite direction, like this. It's like the current move that way, right? The coil is going to be rotating this way. But what that way? Look, we got two rotation. The rotation, the one which goes like a watch, we call it clockwise. Anti-clockwise is the one which goes this direction. This anti-clockwise, but this is a clockwise. This one is a clockwise, but this entire anti-clockwise. Okay, so now we say here, just like I say here, look, the current is going to be moving this way, because this is a positive, it's going to move that way. Oh, so then this coil is going to rotate this way, which is anti-clockwise. See? So same here. Let's look at this. Let's look at this. This is a positive here, right? This is a battery. Remember, this is a battery because more than one cell. Positive. Oh, so the current is going to be moving this direction. See? So meaning, if the current move that way, means this stuff is going to rotate opposite direction. So means for this side here is going to be anti-clockwise. Make sense a little bit? Oh yeah. So if make sure it's not if, make sure you look at your cell. Positive, negative means the current move that direction, so means the coil is going to be moving opposite to that direction, because the current move that way. So the coil moves. So then for this case here in this diagram is going to be at, oh no, my apology. This is clockwise, sorry, this is clockwise. Because move like a watch, clockwise. See what I'm saying? I hope it's very clear here. If you don't, you let me know. My apologies. I'm so sorry for that. This is a clockwise moment because like a watch. And how you know? Because I look at this positive. So means the current is going to be moving that way. So this is going to be moving the opposite to the current. Like the current goes that way, it's moving that way. So for this case, this is clockwise because it rotates like a watch. But that's not part of the question. I just brought that one intentional because sometimes they might change the diagram, you see. So for this one, we know current go that way. It's going to be what? Anti-clockwise. But this one is going to be clockwise. Okay. Now, we done with that? Now they say on 9. Okay. Now they say here 9.11. Is this machine DC motor or DC generator? This is DC motor. Why? Because look, you put your battery, and the moment you put your battery, the moment you put the battery, the current is going to start to flow. And the moment the current starts to flow, for this case, because it's positive, it's going to start to make this coil rotate. Which direction we say? For this case, is anti-clockwise. So the coil is going to be rotating this way, this direction. But for this coil here, is going to rotate that direction, which is clockwise, because of, look at that. See what I'm saying? Just like explain here. Okay, now let's go and answer this question. So the first one, 3.991, which is this is DC motor. Now write down the energy conversion that takes place in the machine operation. This is going to be electrical to mechanical because you place your battery, you insert your battery. The battery means that's electrical. And then when you say the coil starts to rotate, so when the coil rotates, that we call mechanical. So starting from electrical is converting to mechanical. Means the battery is electrical, but when the coil starts to rotate, that's what we call it mechanical. So now we're going to say the energy conversion is going to be electrical to mechanical. Electrical to mechanical. This is conversion. Electrical to mechanical. Electrical. Mechanical. Now 913, write down the name of the component A. Component A is a split ring commutator. Split ring commutator. Split ring commutator. Now they say here, write the name. Okay, that one is done. But sometimes they're not going to ask like that all the time. Remember, this is split ring commutator here. Look. Split ring commutator. See here, they say split ring commutator. It's on both sides, this side and that side. Split ring commutator. But sometimes they may ask you brushes. Brushes is this stuff here. The one on yellow. Meaning for this case here, if they ask for a brush, it could be these black things here, you know. These are brushes. Those are brushes. Now, let's continue. Now, what do they want? They say, in which direction will the coil? So this coil for this case is going to be what? Remember, the current is going to be that direction. Go that direction. Go that direction means this is going to rotate the other way, just like I explained before. So it's going to be anti-clockwise. Anti-clockwise. Excuse me, done. Now, let's go to the next one. Okay, electrical device so we have a power and you have a voltage. See? So let me remove this because we don't want to need this diagram now. Let me remove this. Just a second, sorry. Just a second, let me remove something here. Just a second, let me remove something here. Okay, let's do this. Okay, let me move this. I don't need this one. Okay, cool. And then we say, okay, my apology. So now they say 9.2. So they give us watt and voltage. This is power average, and this one here we call voltage RMS. RMS. Memorize it, okay? That's a power voltage. And how you know that? Okay, these questions always, they give you like that. So the power we have, now they say define the term RMS voltage. So RMS voltage, this is the voltage which is in AC. Okay, this is the RMS voltage is the AC, is the DC, excuse me, direct current voltage is a D. Okay, when you say voltage, it means potential difference. So now when you say RMS voltage RMS, this is the potential difference, is the potential difference, which, okay, let me say this. Okay, RMS voltage, what do you mean? Is the DC potential difference, is the DC direct current potential difference, DC potential difference. Okay, which is gonna dissipate, which is gonna dissipate, which dissipate. Which dissipate, okay, the same amount of energy is the one which is in AC. Some amount of energy, you know, when you say energy means you can say heat or power, same as in AC current. So same as the DC one is going to be same as the AC. Power, same as in alternative current. That's all. So the potential difference, which is going to dissipate some type of energy or heat or power, which is going to be the same as the one in alternative current AC. Now let's go to the next one. So the next one is going to be calculation from this data they gave to us. Now let's see how we can calculate this. Okay, now very important concept here. Power always equal to IV. Memorize this. But for the most case they give to you, power equal to IV. Power equal to current times potential difference. V meaning potential difference, and I is the current, and this P is the power. Now, so they give us information here. They give us power, so P average equal the, whenever they say, oh, electrical device Mach, mean this can be power average. PF, say power average, PF, power average. What is that? Equal to what? Power average equal to 200 watt, and they give a potential difference here. So potential difference, V, potential difference, but this will call RMS. I'll tell you why. Okay, equal to that 220 voltage. So we have a little formula here. Make sure you memorize this formula. They give to you actually the formula sheet most of the time. What is that? This one here. Power average equal to potential difference RMS times current RMS. Can you see that? So you can simply say power average equal to current RMS times potential difference RMS. This is very important formula. So now we come back here now. We say, well, so okay, so well, so we have a power average and we have a potential difference. So this, I'm going to use the formula, say power average equal to IV, but our current is going to be RMS. It's like I showed in the formula, times potential difference RMS. And we have most of the stuff here. Power we got, what is our power? Our power equal to 200 equal to current. I don't know the current. Potential difference, they give to me 220 voltage. So divide by 220, divide by 220. This in this concept. So current RMS equal RMS equal to 0.90 9 ampere. Oh, so this is a current of RMS. But what do they want? Go to the question here. They say calculate the resistance of the device. If I have my current, I can simply use Ohm's law to get the resistance. I'm going to say now Ohm's law. From the Ohm's law, we say potential difference, but remember this RMS, equal to current, but remember current is RMS, times resistance. Resistance is just a resistance. Because from Ohm's law, we say V equal to IR. So I got there. I got that. See? So simply, I can just get my resistance I'm looking for. Potential difference we got. What is the potential difference? They give to us, which equal to 220. Equal to current. Yes, I do have this one, 0.909 times the resistance. Times the resistance divided by 0.90 divided by 0.909. This and this cancel. So our resistance equal to 242. Ohm. Ohm is the unit of resistance. So we got our resistance, okay? 242 ohm. Oh, so we have a resistance 242 ohm. That's the looking for. 242 ohm. Okay. Let's just finish up quick. Resistance equal to 242 ohm. So the resistance. So this one 242 ohm, that's our resistance. Now let's go to the last one. The last one to say here, okay, this device means that device we have is connected to another voltage. Oh, so we got new voltage. So we say, okay, voltage of RMS equal new one equal to 150 voltage. What else do we have? Oh, we have a resistance here, which you just got it. So resistance, remember the resistance is not going to change because the resistance can be the same for the device. The resistance we got equal to 242 ohm. And then what else we have? They give us time here. Calculate the energy in 10 minutes. Oh, so what time? What is the time? Time. This is in minutes, so we have to change it to second. So how you change time to second? Take your time, which is 10 multiplied by 60. So it's going to be 600 what? Second. Now what do they want? They say find the energy. It's easy to get the energy. So look at energy. You just say energy equal take your power multiplied by T. We can change the time. But do you know our power? Oh yeah, we can get our power. So energy we're looking for equal to power equal to IV. We know from beginning power equal to IV. So we're going to say current, but a current is RMS, remember, times V. V of RMS always multiplied by changing time. So now we say, do you have a current? No. Remember, this is going to be new current now because there's the effect of what of this voltage. Do you have potential difference? Oh yes, potential difference equal to 150. So potential difference I got. So I can say my power, my energy, we're looking for energy, equal to current I don't have, current of RMS, times potential difference, yeah, 150, times 600. So let's call this tie equation. So the problem now, I need to get the current of RMS. So what I'm going to do, I can simply say, but I'm going to show you right here under, right? Just because of my space. You see, from Ohm's law, potential difference, but remember it's RMS, equal to current time resistance. So we take current time resistance. You see what I'm saying? But our current is RMS. Resistance is just a resistance. You know what I'm saying? So now what I want to do, I want to get this one here is easy because I can plug my potential difference equal to 150 equal to current, because the problem is this one here. Current, I'm looking for it, current of RMS, times resistance. Oh yes, I had it, 242. Oh, the space not enough. Times 242. 242. Okay, so now we say 242. So now we say we can simply divide by 242 divided by 242. This and this cancel. So plug this in the calculator and then it's going to give us current RMS equal, let me write here, current RMS, because we divided by that, we have a mutual lecture, the current number RMS equal to, take 150 divided by 242. 150 divided by 242. 150 divided by 242 is going to give you 0.6198 ampere. But when you approximate this, is same as say is 0.62 ampere. Current RMS 0.62 ampere. So what we're going to do now, we have to come and substitute here in this type equation. So our energy we're looking for equal to current now we have, which is 0.62, or you can say 0. If you want to use this, you can use that one, 0.6198 times 150 times 600. And like I say, man, you know, excuse me. So we come here and we plug in the calculator. If you plug in the calculator, this is going to give you energy. Excuse me, sorry. It's going to give you energy. Let me just make a space here. Energy you're looking for equal to 800 joule. So this is going to be the energy dissipated in 10 minutes. We're done with that. So now look, if you FaceTime here, like I said, man, we got a lot of program. Make sure you come and subscribe to my other YouTube channel called Untitled Chapter. Go there, do a donation so we can keep the project going. Only if it's convenience, okay? No pressure. You know, we appreciate only when you feel that there's a need for you to do that, so we can let these projects going. However, the projects can always go, you know, by enemies, okay? No makanjan. Now you come here, subscribe also to my channel right here. See, channel bundle, subscribe and share it to a lot of people, because like I say all the time, man, you know, if we not do it, nobody can do it. This is why if you come and visit this channel, you're gonna see how we do for the community, how we inspire, how we help the vulnerable people. Because you see, I grew up in a situation where I always believe, like, you know, the solution most of the time it comes from the outsider, which sometimes could probably be, but everything starts within yourself. See, you start from home. So if we can start face and create something which is giving back, helping people who are, you know, so that they can stand on their own 2 feet. Also, we have another program where we go, you know, visit some dropout kids. Some of the kids that drop out from school, so trying to have them so they can go back to school, you know, connect them to the right people so they can go back to school, because we feel like knowledge is the power, you know. So them having the skills of education is very, very important. So they can have a right to education, because they're our future. See, with them means, look, for example, me, that's me right there when I was 4th grade. See, just imagine if I could have dropped grade 4. See here, that's me right there with my friend. This is a Rasta man. See, so just imagine me if I could have dropped school at the time. Means I wouldn't be the person I am today. So it's very, very important that we have to help the people who need us, even if they might think like, no, we don't need this, brother, we don't need other people. But later, in a later say, they're gonna look back and say, oh man, I was just like another person, yes, just like me. I was just like a lot of these other people yesterday. But because of the inspiration from a lot of people, you know, who inspire, say, give back. A good example is Mago Foley, you know, the president of Africa. Master P from the Calio Projects, you know, who is the former basketball player and a musician also. These people inspire me a lot. That's why I decided to do this program and giving back. You see JT the bigger figure too. You know, JT the bigger figure. Also, he inspired me a lot. Apart from the, you know, look at, that's me right here when I was a little baby. And this is my mom. You see, my mama always inspired me, say, baby, keep on going. Okay? And this is why I'm here today. And it's just only beginning. So go to my online store, you know, whereby click the link below. You're going to see my online store where you can purchase my merchandise, show me support, buy products, you know, and please leave a feedback, because writing the feedback is very, very important. If you don't do that, then it's harder for me to know whether you need this type of video or not. So write the comments below, leave a feedback, say, hey, we're trying to, you know what, you know, your video maybe help my brother, or, you know, I come from KwaZulu-Natal, or come from Nigeria, or come from Tanzania, or maybe I come from Louisiana, or come from Tennessee. See, let me know where you come from. Tell me why you think it's very important for me to continue to do what I do. You see, because I do this for you. It's not only for me. See, thanks a lot of your time, and I'll see you soon. Peace. This is home of mankind. Peace. Follow me on all social media. I'm trying and Kosi. Also, you can follow me in this another one also, Tunnel Bound Academy. Just like I say here. See what I'm saying? Follow me in all those two YouTube channels so that you're not gonna miss out. Thanks a lot of your time, man. I'm gonna see you very soon. Peace in the mouth.